Okay, now the nice thing about a show that one is that you know when you've got to the answer. The nasty thing is if you can't find a way to get there, isn't it? But anyway, this is all about trigonometric identities, and there are two main ones that you've got to make sure you've got at your fingertips. As soon as I see sin, tan, I've got a cos over there, and I know that I want to get it all into coses. I think, well, the first thing to do is to get rid of the tan, and you can turn tan into sin and coses using what I call the mummy of trig identities, which is that tan theta equals sin theta over cos theta. So that's the first thing to do. We replace that with that, so we can just say, right, that is going to equal 2 sin theta times sine theta over cos theta. So then I've got my 4 cos theta take one bit there. And then what I'm going to do next is get rid of the cos being on the bottom. So if I multiply both sides by cos theta, I'm going to swing over this way. I think I'm going to say, right, that's going to give me 4 cos squared theta. And then I also need to times the 1 by cos theta as well to give me cos theta. And already we're starting to look like what we want. And that is equal to, what have we got here? Well, the divide by cos theta is gone, and we've got 2 sine theta times sine theta is sine squared theta. Now at this point, we can get rid of sine squared thetas by using the daddy of all trigonometric identities, which is that sine squared theta plus cos squared theta is equal to 1. And what that means is that I can say that sine squared theta is equal to 1 take cos squared theta. So that's what we're going to do. We're going to substitute sine squared theta with 1 take that. So let's just write that in next. 4 cos squared theta take cos theta equals 2 brackets 1 take So now all we need to do is expand this bracket first of all. 4 cos squared theta take cos theta equals 2 times 1 and 2 times negative cos squared theta gives me negative 2 cos squared theta. And now all I have to do is rearrange. So if I add that, that gets me to 6 cos squared theta. I've got the minus cos theta. I can take 2, and that gets me to 0, and I've showed it. What they want to see is the clear use of both the identities and then the rearrangement. You don't have to show what you've done more than that. Right, next up, hence solve this for that. Now if you look carefully at this, this is just the same thing as this, except that the angle is now 3x. So the idea is we need to use this because this will be easier. So my first step is just to write 6 cos squared 3x minus cos 3x take 2 equals 0. And I'm going to solve for this. Now this looks to me like a quadratic. So what we can do then is I can just say let y, you can use any letter you like, equal cos 3x. And then I can rewrite this as being 6y squared take y take 2 equals 0. So then we are thinking, right, what's going to happen here? I've got to pop that into brackets, haven't I? How do I do that? Well, 6 2's are 12 or negative 12. So I'm thinking numbers that multiply together to make 12. but whose difference is going to be 1. So you've got 1 and 12, you've got 2 and 6, not those, 3 and 4. Aha, yes, and I want it to be negative. So I'm going to say that that is going to go to 6y squared, take 4y plus 3y, that makes the minus 1y there, take 2 equals 0, and then I'm just going to factorise this into two single parts. What goes into both of those is 2y, 3y take 2, and that means that is one of the brackets. What do I times that by to get to that? Oh, just 1, so that'll be plus 1. So what that means is that my factorisation becomes 3y take 2 in the first bracket and 2y plus 1 in the other. So that means that y would equal 2/3 to make that bracket equal 0. Y would equal negative 1/2 for that one. But of course we don't really want y, do we? We want cos 3x. So, and I'm just going to go for, so cos of 3x is going to equal 2/3, and we've got cos of 3x equaling negative 1/2. So they're wanting it between 0 and 90, but we've got 3x here, so I'm going to do it for 3x and then divide everything by 3. So if I do it for 3x, that's timesing by 3, isn't it? 3 times 0 is still 0, but 3 times 90 is 270 degrees. So for 3x, I'm going to have my cosine wave looks like that. I'm only going to need it as far as there, though, aren't I, for 270 degrees. So when, for my 3x being 2/3, I'm going to, that'll be there, won't it? So that's going to give me an angle there that I'm going to get out of the calculator in a moment. A negative 1/2, that's going to give me an angle there, and I'm also going to have to find the difference between that and 180 and add it on to get the other one just there. So I've put that into the calculator, and that's given me 48.18, so to one decimal place that's given, well, actually let's go for a little bit more than that at the moment, because we are going to have to divide, aren't we? So 3x is going to equal 48.1897, shall we say, and for this one here 3x is going to equal 120, but it's also going to be the same distance the other side. There's 180, so that's 60 degrees up to there, so that it'll also be 240. So we then need to divide by 3. So if I just do delete that line and just do answer divided by 3, that'll do it. That gives me 16.06, so that's 16.1 degrees, isn't it? X equals 16.1 degrees, but it also is going to be 120 divided by 3 is 40, and 240 divided by 3 is 80 degrees.